We're going to begin the afternoon session. This session is on domain awareness and lunar exploration. Our first talk will be by Fabio Curti, space-based detection of resident space objects using star sensors.
Thank you.
Uh-oh.
I'm a bit this
Oh,
way.
wait, no, I know what to do now, I think. All right, now it should work. Let me see. Yeah, okay.
Use the microphone.
Okay, thank you. Thank you. And I'm Fabio Curti. I with the Department of System and Industry Engineering. I joined U of A 2 years ago, and my research is in space system engineering. Okay, today I want to show you one of the activity about the use of the star sensor for observing space object. Okay, this is just a sort of overview of mission that are dedicated to focusing on the observation of resident space object, and that are being designed, and even we have a future mission for the detection of object from space. So the main idea, my idea was to use the star sensor. Actually, star sensor are like a small telescope, and they mainly they just observing the sky and looking the star give you the orientation. But because they are even a small telescope, they are even able to detect some objects that are passing in the field of view of the star sensor. This is why I say that is a sort of a dual use of the star sensor. Oh, in here you see this image. This is a real image captured by a star tracker. Okay, the sample time, the frequency is very low, and you see that the blobs are the stars, but you can even recognize some object moving. So this was the main idea, and we start to some years ago. I started this project when I was in Italy, sponsored by the Italian Space Agency, and so why I want to use this star sensor? Because actually, is we can have this information for free. So now we have a lot of mission in which we use the star sensor for the altitude determination, and so it's like having a sort of constellation space observers for free. So in here, this is just a feasibility analysis that I want to show you about the relative distance that we can from which we can detect our object, considering just a magnitude of 5.5. That is a very common magnitude detected by the star sensor. And you see that, okay, this is just a theoretical results. But actually, we developed a very high fidelity star sensor simulator in which we can even simulate the object in the orbit. This is more or less is the system structure, architecture of our system, in which we have software that can run within the star sensor, able to recognize the object. But the object that is, okay, in that image, you see just a blob moving. But actually, in the real image, what we have is a streaks that we can detect with one image. So this is why this is why let's say the architecture of our system is taking consecutive image, just comparing a couple of this image, and then we can reconstruct. We can recognize if this is an object or not. And actually, I want to point out that usually what we have for the real star sensor is that if they recognize a streak, for them is just trash. So in this case, what we take is the trash from the star sensor, and then we analyze if is an object. So in here you can see that we needed to develop a new technique to process the image. And okay, I just quickly, we have a first phase that is a software preprocessing, in which we take all the pixel over a threshold in terms of energy. We collect energy from the object. Actually, we developed a method using the UNet to improve this process. So, but even I don't know why. But okay, we introduce other filtering technique. For example, the distance and the length and the density. For what? Because actually, when we have these streaks, we have several groups of pixels. So we need to link together this information in order to have the final streaks. That is our object. So this is another. Okay, I just want to show you this. This was a real test that we did in Italy. On the left is two images overlapped. In here, we didn't use a star sensor. We used just a camera. And even the acquisition time cycle is 5 seconds, but usually in a star sensor, we have 0.1, 0.2 seconds. So on the left, you see the International Space Station. Maybe you can recognize which streaks is the International Space Station. The other are stars, but we developed another technique to remove the stars from the image. So on the right, what you see is the International Space Station acquired by a camera. And another problem that we solved is that if we are on board for example, we are moving with our spacecraft just for retargeting our spacecraft, what we have is streaks coming from stars. You can see all the streaks that are parallel, that are moving together, they are stars, while our streaks, that is an object, is another one. So we just introduce a sort of criterion to select the correct streak. Okay, 2 minutes. Okay, in 2 minutes, just to say that okay, we did several simulation with our simulator, and you see there on the top right the percentage of object that we detected, a sort of success that we had for different distance, and on right for different magnitude. I just want to stress that when our object is very close to us, let's say 250 kilometers, is very fast. So it's moving very fast as a relative velocity. So this is why we can collect very poor energy from that object. This is why you can see that the performance are not good when our object is close, orbiting close to us. And finally, okay, we propose this as a software device to run inside the star sensor, but even we developed a payload that you see here. And because actually, okay, the project is finished, but I want to keep going these activities in here. And I have the payload, so I'm looking for something that can give me a ride to go into space because I want to test in orbit this system. And the other is that as a future work, we want to apply some AI technique for this, for the detection. Actually, we have some preliminary results in the publication that you see there. And the other very crucial point is the orbit determination using a very short arc, because when I see my object, I can see my object for 20, 60 seconds. So using the classical technique for the orbit determination, we cannot have results. So this is why we are investigating, and we have just preliminary results in another publication, how we can fix this problem, we can solve this problem. Okay, thank you. Questions, sorry. Yeah.
I was just wondering how much of the star tracker data is usually the full frames all available, sent down usually, or is the idea that this is going to be done on board and then you just have to
No.
send
The
out?
idea is to process the image on board.
Okay.
The idea is to have this software inside the star tracker, because we use the same image. The star tracker uses the image to give you the quaternions. I use the same image to give you the object.
Okay,
Okay.
thank you very much.